Episode of our Python game development series, we are going to focus on writing algorithms, like I said in the previous episode as well. So in this one, we are going to focus on what we should calculate when we click on a cell in terms of how many mines are located surrounding the clicked cell. So it needs to bring in a lot of functions, a lot of methods, and some more data that we should put in each of our cells. So that is going to be very exciting writing this one because there are multiple ways to achieve what we want to achieve right now. And in this episode, we are going to do that as efficient as we can. So I believe that it will teach you a lot in terms of writing efficient code with Python. And with that being said, let's get started. Alright, so in that episode, we are going to design what we should do when we left click on a cell. So first things first, we should be deleting the text that we have wrote to each of the cells here, which represents the x and y axis values. So let's go ahead and delete this first. So I'm going to take that line off because this used to be the text of the cell. So I'm just going to make that to be equal to nothing, and then we need to decide what we are going to display here once we left click on a cell. So let me re-execute the game like that, and now we can see that we don't have anything. So the expected action here is whenever we left click on a cell, then we should be displaying a number, which that number will represent how many mines there are surrounded that cell. So what that means, it means that if that's a mine, and that's a mine, and as well as this one, then we should be displaying here 3, because this cell should figure out how many mines there are surrounding that cell. Let's take one more example here. So let's assume that we clicked here, right? Then this cell should start thinking how many mines there are surrounded this cell. So this means we talk about all those cells. Let's say that we have a mine here, right? We have one mine there, and all of those are not mines. So we should be displaying here 1, right? So that's going to be the main goal in that episode. And it's going to take a lot of algorithms that we should be writing inside methods inside the cell class. So it's going to be extremely challenging and also fun doing that, and let's go ahead and get started. Alright, so I'm going to start by scrolling down to the left click actions, and then I'm going to delete everything here and start writing here some actions that we need to take. Now, one of the first things that we want to write here is an if conditional that will check if that cell is actually a mine. And I can do that by writing if self.isMine. So the reason that I can do that is because I know that in the beginning of the game, I already called this method that is called randomizeMines, which takes a couple of cell objects and then it sets isMine equals to true. So I can totally do that. And then if the clicked cell is a mine, then I want to start taking several actions. So those several actions are also going to be located under a method that we can write right now. So if self.isMine, then I can go ahead and say self.show_mine, something like that. And that is just a theory. I know that showMine is not a method that exists right now, but that's what we're going to do just right now. I'm going to go out of that method, and then I'm going to say def showMine, and I will receive self as a parameter for sure. Alright, so in that method, I'm going to basically write the actions that will be responsible to display this cell as a mine. Now, we know that here we should write a logic to interrupt the game and display a message that player lost, right? Something like that. But I'm not going to do that temporarily because it is going to be too much annoying to stop and terminate the game every time that I click on a mine while we develop that game. So converting the background of that cell into a red background color should be enough temporarily. So I'm going to just say here something like the following: self.cell_button object, and then I'm going to configure the background color of it. So if you remember, when we use tkinter objects, we can use this configure method, which will be responsible to configure our elements. So as an example, I can go ahead and say here bg equals to red. Now that is equivalent to what we have done with the frame. Let me show you that by splitting vertically. You can see that we took our window here and we used dot configure bg equals to black. So what we do here an action that is quite equivalent. Whenever we click on a cell, we check if that is a mine, and if it is, then we'll launch that method, which will be responsible to configure the background color of that to red. And that is just a perfect beginning. So if we run our game and we click on a couple of cells, then you can see that this is a mine. So that's why it has been colored to red. So that's a great start. And I realized that I had a typing mistake here, so this should be a logic to interrupt the game and display a message that player lost. Alright, so now that we have done this, then we should be also designing what we should do if the cell is not a mine. So here is the exact location that I should be say else, and then I should launch a method that will say self.show underscore cell, right? And here is going to be the complex stuff, because we need to display a number that will represent the amount of mines that are surrounded the clicked cell. So I'm going to go here and I'm going to indent out from these left click actions, and I'm going to say here def show underscore cell, and we will receive here self. Let's say pass here and explain what we're going to do here just in a second. Now I zoomed out a bit to the beginning of our class, because in order to explain what we should do now, I'm going to again bring back the text that we used to have here, which was self.x comma self.y, because I want to display the axis x and axis y values, because that's going to be helpful to explain what I'm about to explain right now. So I execute the game here. You can see that again we have the axis x and y values. Now in order to start calculating the amount of mines in the surrounded cells whenever we click somewhere, then we should be using those axis x and y values for sure. Because think about the situation that we clicked here, right? Let's say that we clicked here right now. So we should start iterating over the cells that are surrounded that cell and check if each one of those are mines or not, and then somehow we should be collecting the amount of mines and display it here. So that's a lot of actions that we should be taking. Now we can understand that having a method that will receive the x and y as a parameter and then will give us back the object of a cell is going to be extremely helpful. Because think of a situation that you click on that cell, you want to check the attributes of this cell, of that cell, and also this cell. So we can already start understanding that if we will have a method that will return the cell object depending on the given x and y values, is going to be extremely helpful. So that's going to be the first step that we should be taking right now. We should be writing a method that we can call it getCell by axis, and then this will return us back an object of the cell. So let's go ahead and write that. Alright, so I'm going to go here to that line above the show cell, and I'm going to say something like def getCell by axis, and then I'm going to receive here x and y like that. And the actions that we want to do here is basically return a cell object based on the values of x and y. That's all. That's everything that we want to do here in this method. So now we know that we have this list that is called all, and we can basically start iterating over this list of objects to find the cell object that we need based on those x and y values. So I'm going to go ahead and start with a basic filtration that will help us to give us back the cell object that we need. So I'm going to say here for cell in cell.all, and just pay attention that I'm using the class name, so C should be in uppercase, and then I'm going to say something like the following: if cell.x is equal to the given x argument and cell.y is equal to the given y value, then we should be using here return cell like that. Now the reason that I can do this, it is because whenever I'm going to have a match in those x and y attributes, then I can immediately stop my iteration and just return that object. And that's going to be helpful because whenever we want to display the cell, then we immediately want to see what is going on inside the surrounded cells. So that's a method that is going to be really helpful again, and that's going to be something that we are going to understand in a couple of minutes. Alright, so the next thing that I want to do now is to call that method and basically print the result of that inside the show cell. Now just a kind reminder, if we take a look in the left click actions, if the clicked cell is not a mine, we are entering here in the else statement and we call this show cell method. So if we go here and say print self.getCell by axis and we pass in just random values like, I don't know, 0, 0, then we should see the object specifically where the x attribute is equal to 0 and the y attribute is equal to 0. And that is not going to be a matter which cell I'm clicking here, because I just bring the object where x and y are equal to 0 both. Alright, so let me launch the game now and see what is going on here. So if the click cell is not a mine, then we should see the object, right? So let me make the console bigger and I'm just going to click on 05, and that was a mine, so we did not see anything on the console. Let's click on here and you can see that I see the object cell 0, 0, and that was a mine. Going to click here, this is a mine as well. That's not a mine, so that is a perfect result. I'm also going to click here. You can see that we have a perfect method that returns the object based on the given x and y values. So let me show you in a separated window why that's going to be helpful having such a method. So imagine again that we are going to click on 1.1 as an example, right? So we're gonna need to collect all those 8 cells that are surrounded the clicked cell. So this means that now we have the control to bring this one, and this and that, and this and that, and also those two here. So in order to show what we should be doing right now with the getCellByAxis method, then I'm going to work on this side notepad that I have here. So let's imagine a situation that we really clicked on 1.1. So if we click on 1.1, then we should be bringing the cells that are 0.0, 0.1, 0.2, right? So those are going to be those 3, right? And then let's continue on. So we should be also bringing 1.0 and 2.0, and those are going to be those 2. And let's continue on. For again clicking on 1.1, we should be also bringing the cell of 2.1, 2.2, and those are just going to be those 2. And then we also have 1.2 that we should bring, and that's going to be also written here. So you can see that we have a formula that we should be following. So now let's go ahead and implement this in our code. So I'm going to delete all the drawings here and I'm going to go back to our actual code. So first things first, I'm going to delete this one, and then I'm going to just do something like the following. I'm going to make a list that is going to be called surrounded cells, and that's going to be equal to a list, and that list is going to include those 8 objects. Now those 8 objects could be basically pulled from this getCellByAxis method. So first it's going to be self.getCellByAxis, and for 1.1 we should be decreasing the x by 1, and we should be also decreasing the y by 1. So first one is going to be self.x minus 1. The second value is going to be self.y minus 1, like that. So we can allow ourselves to check the first cell that we should be pulling, right? So let's go to the second one. And don't forget to add here a comma, because we have a list that is going to include 8 elements, and we should be comma separating them. So the second one is going to be self.getCell by axis, and now the formula is going to be decreasing the x by 1, and the y value is going to be the same, because as you can see, the y value here and the here are the same. So I'm just going to pass in here self.y, and again comma separated. And in order to be organized, I also going to say here v to mark it as a checked cell. So the third one is going to be self.getCell by axis, and again the self.x is going to be decreased by 1, but this time the y value is going to be increased by 1, because that is 2 here. So this is now also checked. I'm going to add here a comma, and now I'm going to say self.getCell by axis. I'm going to pass in the same self.x because the next value is 1, and then the y value is decreased by 1. So it's going to be self.y minus 1, like that, and that's also checked. And now I'm going to jump on to the next one. It's going to be getCell by axis, self.x plus 1, because the next one is 2.0, and then I'm going to pass here self.y minus 1, right? And that's the fifth value. Going to check that. The sixth one is going to be, so the previous one was the fifth value, and that's going to be the sixth value. So self.x plus 1 again, and the y value should be the same. Going to close that, add a comma, mark it as a checked cell. Going to do this 2 more times, self.getCell by axis. Now you can pay attention that both x and y values are increased by 1. So I'm going to do exactly like that, plus 1 for both. And then the last value is going to be self.getCell by axis. We're going to be passing the same x value, and then the self.y is going to be increased by 1, and we can allow ourselves to basically write a check for all the 8 cells. So now that we have done this, then we can allow ourselves to first print it to see if we have done a great job, right? So I'm going to say print surrounded cells to see that we have done a wonderful job, and let's go ahead and check ourselves. So I'm going to execute the game, stop and rerun. So we are going to click on 1.1, and we should see a list with 8 objects. Let's follow up what is going on here. So 0, 0, 0.1, 0.2, 1.0, 2.0, 2.1, 2.2, and 1.2. So perfect, right? Perfect job. We brought everything that we need. And if we count this 1, 2, 3, 4, 5, 6, 7, 8, it really seems like we have done a wonderful job. Now, the problematic thing could be if we click on a cell like 0.0, because this has 3 surrounded cells. So this might lead to not working, but let's see if that's going to work. I believe it's going to work, and it is going to pull the 3 objects like expected, 1.0, 0.1, and 1.1. So I'm going to click on 0.0, and you can see that that is quite what happening, but you can see that we receive none for all the 5. Because what is going on here? If we click on 0.0, then at some point this getCell by axis is going to receive negative values, because whenever we click on 0.0, then a -1 value could be passed. So we need to eliminate those nones when we write this surrounded cells list, and that's something that we're going to take care later on. But until now, a perfect job bringing on these surrounded cell objects, and let's continue from here. Alright, so now that we have done this, then we said a minute ago that we're going to take care of the non-values that we had inside our list. Now that is something that could be done by list comprehension. Now a list comprehension means to create a list by a one-liner that is going to immediately take care of something that you want to take care right now. So in order to take care of eliminating the non-values inside the list, then you can use a list comprehension expression in order to handle the non-values and just get them out of your list. So what we are going to do now is we are going to override the surrounded cells list, but we're gonna need to use a one-liner list comprehension in order to eliminate the nons. So that's going to be something like the following. So surrounded cells is going to be equal to a new list, which is going to look like the following. So what we really want to do is to have the exact same list, but we want to eliminate the nons. So that is achievable by doing something like that. So you can use a one-liner for loop inside your list in order to take care of something immediately. For example, let me show you how we can do a for loop in one line. So you can say cell for cell in surrounded cells. And now that we have done this, let's see the results. Right, so I'm going to print surrounded cells and pay attention that I'm overriding the value of this one by again using the same value and assigning something new to that. So I'm going to again execute our main.py and let's show what is going to happen if we click on 1.1. You can see that the result is pretty much the same, and if I was to click on 0.0, then again the results are the same. But whenever you used a list comprehension and you include inside of that a one-liner for loop, then you can use an if statement that will take care of something that you don't want right now. So I can go ahead and use an expression here that will look like if cell, meaning the iterated value, is not none. So that's going to eliminate out our non-values, and that is exactly what we want. So again, I can re-execute our program and see if that's going to work. So if we were to click on 0.0, we see the perfect result, right? We see 3 elements inside our list, and that's also something that we may want to test with a cell like 0.1, because if we count the surrounded cells, then we have here 1, 2, 3, 4, and 5. So if we click on that, then you can see we have 5 elements inside our list. So that is a perfect way bringing the surrounded cells when we click on some cell. Alright, so now that we understood this, then I'm going to move all those lines of code into a separated method so that we could have a property that is going to represent the surrounded cells object. Now, a property is basically like an attribute that is read-only, and you can mark those attributes as read-only attributes by using a decorator. So let me show you how that's going to work. So I'm going to just copy everything from here, and you know what, just cut it like Ctrl X and not copy, and then I'm going to say def surrounded cells, and this will receive self, and I'm just going to leave those code snippets here, and then I'm going to say something like return cells, and I'm going to be changing those variable names to cells, and also this one, and as well as that one. Now, the reason that I'm doing this, it is because I don't want to have the same variable name as the name of my method, because that could lead to a lot of problems. And I said that I will be converting this into a read-only attribute, and that's achievable by the property decorator. So above this method, I'm going to say add property, and now you can just use it as an attribute, exactly like the attributes that we have here in the init. So now that we have done this, then I can allow myself to go back to show cell and validate that I have done a great job, and I can use here self.surrounded cells, and you can see that I have an auto completion, and that is just perfect. Now I can access my surrounded cells by accessing this property from here. Alright, so now that we have a method that brings in the surrounded cells objects, then we need to iterate over the surrounded cells objects and identify which one of those are mines and which of those are not mines. So that's going to be taking in one more method that is going to be responsible for that. So I'm going to again create a method here that is going to look like surrounded cells mines length, and you can understand what this method is going to do. It is going to count the mines that are in the surrounded cells whenever a cell is clicked. So I'm going to make this logic as easy as saying first counter equals to 0, and then I'm going to iterate over the surrounded cells objects. So it's going to be for cell in self.surrounded cells, and I'm going to check if cell.is underscore mine. Then I'm going to increase the counter by 1. So it's going to be counter plus equals 1. And at the end of the day, I want to return the counter back and just use it. So it's going to be getting out of those for loops and if conditional, and then just use return counter like that. Now, just like we have done with the self.surrounded cells, I can also allow myself to use the surrounded cells mines length as a read-only attribute. So I'm again going to go above this method and I'm going to mark it as a property like that by using this decorator. Now, I did not mention this early on, but if you don't know what is the property decorator, then I have an object-oriented programming series that you can go ahead and take a look, and I bet that it is going to be a very informative video if you never heard about this property decorator, which is an extremely useful thing when we write object-oriented programs. Alright, so now that we have done this, then I can allow myself to do something like the following. So I want to go inside the show cell, and I just want to be seeing the length of the mines, meaning the amount of mines that I have whenever I click on a cell. So that is just going to be a great test for our game. So if we click on a cell, then we can allow ourselves to print self.surrounded cells mines length. And let's go ahead and see if that's going to work. So I'm going to execute my game, and for example, let's assume that I'm going to click on 0.0, and that is a mine and I'm fine with it. And that's also a mine, and let's click on here. So you can see that I see 3 in the console, right? Because I clicked on 1.1. And what that means, it means that over here we have 3 mines. So let's keep on and continue clicking on some cells. So we already have 2 mines here, and we should be having 1 more inside these surrounded cells. So not here, not here, not here, not here, also not here. Okay, so we have a mine here, and if we click on here, so that's not a mine as well. So that is perfect. That is really perfect, because around this one cell here, we have 3 mines, and this means that we have completed writing this logic in the best way that we can. Alright, so there's going to be one more thing that we want to do immediately when we go ahead and click on a cell, and that's going to be displaying the number of mines that are surrounded that cell. So now that we have control with this surrounded cells mines length, then we can allow ourselves to change the behavior of this show cell method, and we can go ahead and just configure the text of our cell to display the amount of mines surrounded that cell. So that's going to be something like the following. It's going to be by accessing to the cell button object and configuring the text. So I'm going to use the configure method again, and I'm just going to say text is equal to self.surrounded cells mines length, and that should be enough. And now I can really allow myself to delete the original text that we had previously. So I'm going to scroll up, and I'm going to go back to the method that helps us to create the button object, and I'm going to take off this text from here. Just delete that. And then I'm going to execute our game, run the program, and let's click on some cell. So you can see that we have 2, and this means that we have a cell maybe here that is not a mine. So this means that for sure that is a mine, and that's a mine as well. So perfect. Now we really start to have a real game going on, and that is pretty much what we want to do in that tutorial. We wanted to write the logic to display the amount of mines that are located in the surrounded cells whenever we click on a cell. Alright, so that will do it for the 4th episode. If you enjoyed in that one, be sure to hit the like button and as well as subscribe to my channel so you will not miss the future episodes, which are going to be extremely challenging as well. So see you next time.